Hello everybody, my name is Anthony Wong, and in this video we're going to talk about the physics of bouncing ball, and specifically the physics of the rotation and translation, how to match the rotation to the translation. A little bit about myself: I teach at Animation Mentor Class 1, and I have been working in the industry for more than 30 years. Work as a 2D animator at Disney for 10 years and another 20 years at Pixar. You can treat this as a supplement to your bouncing ball lecture and your bouncing ball homework. The first thing I want to talk about is understanding the bouncing ball pattern. And that's a big concept I want you guys to take home, which is that your TY, your up and down, your front and back movement, they are independent. They are not related. That means you can treat each of them individually. So this is a bouncing ball animation I did for the demo. This is your first bouncing ball assignment with the sensibility of a soccer ball or basketball. This is your most basic model. When I click on this, you can see that this is my TC curve, the forward movement. The TC curve and the rotation, they are related. As a matter of fact, they're the same curve, but at a different scale. This is my TY, the up and down. And the gap here is where the ball gonna roll, because the bounces stop and it's all rolling here. And I put the roll back at the end. So that's how it looks. And to demonstrate my point that the TC and your TY are independent, I can grab the TC curve and make it travel less. So like so. And it's not gonna hurt your TY. The rotation's a little bit off because they are related. Or I can make it travel further. You don't have to do anything to your TY curves. Now this is up and down the scale, the range of travel with TZ, right? If I push the TZ down the timeline, that means now your ball gonna last longer. And you see how it affects the path, but the TY curve stay the same. Now you're gonna roll more. I can make the ball last longer and roll further by pulling it down the timeline and further distance. I can just play with that without touching my TY. And you can see from here, my TZ lasts this long, right? Which means that I actually have room for more bounces. If I want, I can squeeze in a few more bounces without worrying about the TZ, or I can make the bounce last longer. So now it's float here without changing the TZ. Now the ball gonna look lighter. When you do your bouncing ball, turn on the motion trail. Grab the root here and go to visualize, create motion trail. It will give you this motion trail because it helps you to see the signatures of a bouncing ball. So the gap here for each bounce, the gap is your timing. So it literally is like a countdown. Bam, 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 getting smaller and smaller and smaller. So it go 14, 12, 10, 8, 6, 4, 2. And you got this pattern because during each impact, the ball loses some vertical energy. And that loss of energy is also echoed in your TY. So you got lower and lower and lower and lower. Which also means that there should be a logical decrease of your TY too. A lot of beginner mistake is that they have these irregular, I'm exaggerating it, but kind of lack of discipline for your TY. Even if you got the timing correct, when you plot a line on the peak of each bounce, it should be a straight line or more concave line. The more concave the line, the heavier the ball will look. And let's talk about TZ. Your TZ doesn't have to deal with gravity. Your TC has to deal with friction. So your TZ is fast out, ease in. Your TC curve is no different than your car assignment, which have the fast out, ease in curve. So you're reusing what you learned before. Now you got the timing figured out, you got your TY decay worked out. You got one more thing to consider, which is spacing. which is this. You see the little crosses I put in the motion trail to track the spacing of the ball. You want the gap going into the impact bigger than coming out. Okay, bigger, hit, less coming out. More going in, impact, less coming out. So on and so forth. It makes sense, right? You got more energy coming in, impact, you lose some, and you get out, then you got less. And why is spacing important? Because if you reverse the spacing, you get yourself a jump. That's the spacing for the jump, even though the timing is the same. And let's talk about how to get these kind of crosses. So we go to your outliner, find the motion trail, right here, motion trail. Go to attribute editor, scroll down to find frame markers, right here. Turn off, turn on, and then you can give it a color. Let's see, let's use yellow. So you can get yellow and make it bigger, smaller. You can even put frame number if you want to, but they're too overwhelming. So I turn it off and make the color brighter or darker. And this is really helpful, especially when you're going to polish. Now we're going to talk about matching your rotation with your forward movement. I took out the rotation, so there's no rotation right now. One way to do it, just simply eyeballing it, and it's legit. You can do that. So let's try that. So you can go to the root RX, make a key there, key selected, so that's your key to work on. And get to the end of translation, the TZ right here, and get the auto key turned on so that when you rotate, it create a key. So rotating this way, right? So I just rotate. And then just see how it goes. Sliding, right? So you know that you increase the scale, and also you want to match the sensibility of your TZ. In this case, I have a key there, right? So I want to match that. And I can go to view, normalize view, so they overlap each other. And get their sensibility. So they look similar. As they should be, because they're related. And you can see that just by looking at this. I can see this guy can be a little bit more. Like so. And let's play it. This is but just by eyeballing it. Okay, not too bad, right? Maybe sliding a little bit so we can increase it. Yeah, something like that. And then, just done by eyeballing it, adjust the curve to your TC curve and scale it up and down to get to the point you think is matching. Another way to do this is actually use math to solve the problem. When you see these two curves here, it's pretty obvious that they are related. That means you can copy and paste your TZ onto your rotation. So let's do that. So in this case, if your rotation is a bit more complicated, like hit a wall, come back, and then roll a little bit, and then have a roll back kind of thing, you can still do that. You no longer need to eyeball everything. So I take out the rotation key, I copy, and paste onto the RX. I go to RX, make sure that you have a key in RX, and then you paste. It's a regular paste. Now your TZ and RX is the same curve. Let's play it. You see it sliding, right? But everything is matching. The sensibility is matching. You know there's a relationship between them. So what's the relationship? The relationship is this. You need to scale up your RX by 2.73. Scale, option, 2.73 under the value. Apply, and then is dead on. Right here is dead on because it's math. And let's explain the logic. So let's talk about where I got that factor, the number 2.73, the ratio. So you have TZ here, your RX here. And let's say a ball radius R. For a rotation going 360 degree, 360 unit, one full rotation, how far does a ball travel? Here, one rotation means it travels one circumference. So it's 2r pi. So 1 TZ equal to 300 divided by 2r pi. And in this case, your R, your radius, for the advanced ball is 21. So it's 360 divided by 2 times 21 times pi equal to 2.73. And how do you get the radius? You can get the radius from using the measure tool in Maya. Then go into create, measure tool, distance tool. Click. And you get the little cross there. Click here. Click here. So about 42, your diameter is about 42 units. So the radius is half of it, so 21. Which means that if your ball is bigger, smaller, you can go by the radius and find a different factor. And to delete that, you can delete it from Outliner. The locator, you can delete that. You gotta go back into animation mode, translation mode, to get out that measure tool. Okay. So let's do an experiment. So if I scale this up by some odd number, 2.34, okay. Now the rotation is too much, right? So let's find out the relationship. So go to create, measure tool, distance tool, here, is 96.3. So let's do some math. So 360 divided by 96.284 divided by pi 0.1416. So now your factor is 1.19. So let's try it. I need to get out of the measure tool. Click on here. Now I can select. So same thing, copy this, copy. And then we paste onto the rotation. Same thing, delete the rotation. Paste. So they're exactly the same curve. And then scale. And this time the factor is 1.19. 1.19. Apply. It's dead on. And another thing you can do with your basic bouncing ball is you can add an extra rotation so that the ball roll has a little bit more three-dimensional quality to it. And what you can do is you can put a little bit RZ into your animation. And do the same thing. So you can copy and paste your TZ onto RZ. Now right now it's too much because going all over the place. You see RZ give you a little bit. You see RZ give you a little bit that dimension, like give you a little bit that dimension. So once you paste onto it, you can just scale it way down. Scale it way down. So that is there, but you don't notice it. So something like that. And let's see. In here, I'll actually move the whole curve up a little bit. So in here, I see a little bit of bottom of the ball. When I finish, I see a little bit top of the ball. To add a little bit more dimension to the rotation. But it's still based on the same curve. So you got same kind of sensibility. And again, you see how all these noises here after you use the measure tool. How do you delete it? Remember, you go to Outliner. It's right here. You got that like an anchor kind of icon. Grab these and just hit backspace. Adios. All gone. Okay. A quick note about matching your rotation RX to your TZ. For those people who use TX as a forward movement, then you gotta negate your RZ. And it's not difficult. Just when you do the scale, just put a negative sign in front. So negative 2.73. That's all it is. And this copy and paste technique applied to situation when you have a rollback. It makes rollback much easier to do. You see how the ball have extra dimension? I put a little RC to it, but you can see that it's the same curve. And the way I do my rollback is this. So I put a breakdown on the TZ to control how the ball goes in, how the ball slow in. And then I use an overshoot to have a little kind of almost stopping but not stopping kind of energy. If I want, I can make it flat if I want to. But I like that little roll. That means the ball not quite really stopping. And then come to a stop. And when you stop, make sure the tension is flat. Like nothing like tilted. Make sure it's flat. You can push this button to flatten it. That's the rollback. It's very subtle. And also, one advice for you guys in class 1, which is just keep your heavy light ball and your bouncing ball simple, especially this one. Remember, it's not about how creative you can do with the bouncing ball. It's have a strong foundation to build things on. It's boring because it's supposed to be. This is your Honda Civic. This is where you're going to build your heavy light ball on top of it. This is where you're going to build your tailor on top of it. So another thing to take away is that the tailor is your finale of your bouncing ball. Once you get all your fundamentals, now you can go crazy with the ball. You can cheat, you can use squats and stretch, just make them bounce. And then on top of it, you have a tail. Cool? Alright guys, so that will be my video for today. You got questions, just email me on campus at Animation Mentor. I'm Anthony Wong, and good luck with your animation study.